Let us solve a tricky question on price elasticity. Question is, if Q is equal to 20 upon P, where symbols have their usual meanings, at what price the elasticity of demand would be unity? Options are 23, 1 or all of these. Okay. So basically what we are being given, we are being given the demand function, that is Q, that means quantity demanded, is equal to 20 upon P, denotes the price of the good. Clear? We are being told to find the price where the elasticity of demand would be unity. By unity we mean it is equal to 1. That means we are supposed to find out the price where elasticity of demand will be equal to 1. Okay, we are taking the absolute values here, no problem. So first we should know what is the formula for elasticity of demand. We know it is simply equal to the derivative of demand function with respect to price times price into Q. Okay, having said that, first we need to find out this very derivative, that is dq upon dt. That means we need to take the derivative of this function with respect to price. Okay, so for the sake of simplicity, if I write this, and let me write it here, Q is equal to 20. If I transpose this P to numerator, it will become P raised power minus 1. Okay, I'm just trying to make it more simpler for you. Now if I take the derivative, that means dq upon dp, so we apply here power function rule. Okay, if we have x raised power n, its derivative is n x raised power n minus 1. Exponent becomes coefficient and exponent is subtracted by 1. So in place of x we have p. So first we write 20. Derivative of p raised power minus 1 is simply minus 1 will become coefficient. Then we have p, and this minus 1 will be subtracted by 1 by power function rule. So it will become minus 20 p raised power minus 2, or we can rewrite it in this fashion, that is minus 20. Again, if I transpose it to denominator, exponent sign will change, it will become p square. Okay, so dq upon dp will become minus 20 upon p square. Okay, then what will be the price elasticity? Price elasticity, so price elasticity, we know it is equal to this dq upon dp. So in place of dq upon dp we have minus 20 upon p square. Okay, into, then we have p divided by q we know it is equal to 20 upon p. Okay, so this stuff I am taking absolute value here, so it should be equal to 1. If I rewrite this, so I can write it in this fashion, minus 20 upon p square. Okay, if I write 1 here to make it simple, so we have p upon 1 into, if I transpose this, it will get reciprocated, it will become p upon 20, and it should be equal to 1. Okay, taking absolute values, I should have taken this absolute value at last too. Okay, so I will not mess up here. So here we can see it becomes minus 20 upon p square. Then we have p into p is p square upon 20, and it should be equal to 1. Here you can see 20 and 20 gets cancelled. P square will also get cancelled. So in place of p square, can't I write minus p raised power 0 is equal to 1. Okay, then we take absolute value of this, minus p raised power 0, so it will become p raised power 0 should be equal to 1. Okay, now For different values of p, price elasticity of demand will be equal to 1. Okay, if in place of p we have, let us say 20, so we will have 20 raised power 0, again it will be equal to 1. If I write in place of p we have 3, so 3 raised power 0, it is again 1. So we know that anything raised power 0 is equal to 1. That means the the price at which elasticity of demand will be unity will be all of these numbers. In fact, any positive number will be uh, you know applicable here, so that the elasticity of demand would be unity. Why? It is a special case. It is a case of rectangular hyperbola. Okay, rectangular hyperbola is a demand curve where the elasticity of demand remains same at all points. If we have quantity on this side, price on this side, this will be our 20 upon p, that is our demand function. So elasticity at any point on this curve will be equal to unity. Okay, I hope I make myself clear in this video. Thank you.